welcome back. We're going to be looking at using the distance formula in parallelograms in order to determine if the parallelogram, or rather the quadrilateral, is indeed a parallelogram. So let's start off first by recalling what the distance formula even is. So let's start off with our title, little here, the distance formula. The distance formula is usually written as d, though we can replace this with some sort of notation that says the distance of a particular line segment. You'll see that later on. It's equal to the square root of, and now we have a bunch of stuff to write. So in parentheses, we're going to subtract the x coordinates. When we're done subtracting, we're going to square them. So we note that by putting them in parentheses. We're going to do the same thing to the y coordinates, subtract them, and whatever we get, we'll square root them. We'll square them. Once we have the two values of x and of y, you're going to add them. When you're done adding them, you will take the square root of the entire number. That's what the distance formula is asking you to do. And so let's take a moment to figure out how we can use this in order to say that parallelograms are congruent. You first need to look at your properties of parallelograms, and I'm going to pull from some previous notes here. Because we're working with distance formula, it's going to tell us the length of sides. And out of these 5 different properties in parallelograms, the only one that tells us anything about length of sides is this one. Opposite sides are congruent. Congruent means same size, same shape. And so for opposite sides to be congruent to each other, they need to be the same length. Or in other words, have the same distance. And so that is the property that we are going to be using in order to decide if in fact a quadrilateral that we are given is a parallelogram. Let's go ahead and use these coordinates. Again, I'm pulling them from an example from our textbook, which you can find on my shelf if you're here in my classroom. So these are the coordinates that we want to know make a parallelogram or not. First thing I'm going to do is I'm going to give this a quick sketch so that I can see what it looks like. As I'm looking through the coordinates, I notice that I have a lot of negatives, and so I'm going to really focus in on the negative quadrant that's here. I have my x and my y, and it looks like I only go up to -6, so I can make my scale here pretty big. There's 3, 4, 5, and 6 without any worries. So 1, 2, 3, 4, 5, and 6. All right, let's go ahead and graph these points. It looks like A is going to be over here at -6, -5. 2 is at -1, -4. C is at 0, -1. And D is at -5, -2. So right about there. Again, I'm going to pull out my trusty straight edge just so that when I draw them, the lines look very neat and very beautiful. If you're doing this on graph paper, you should be able to see whether or not this thing looks like a parallelogram. Because I didn't draw it on graph paper, my scale's all wonky and my lines are kind of crooked, this doesn't really look like a parallelogram. So we've got to confirm it. If you're drawing it on graph paper and it looks like a parallelogram, congratulations, but that doesn't necessarily mean that it is. You still have to confirm it by confirming whether or not the opposite sides are congruent. By confirming whether or not the opposite sides have the same distance between their vertices, between the points. So let's go ahead and take a moment to do that. We're going to find the distance between A, D, and compare it to the distance between B and C, and I'm hoping that they are congruent. So I'm just going to put a little X here to show that this is the ones that I'm working with right now. All right, so I want the distance between A and D. The way you write distance between 2 points is you just write the names of the points one right after another. All right, here's my formula. So x2, doesn't matter which order, but please pick one of your points to be x1, y1. The other one becomes x2, y2. There's the selection that I have made. I wrote it in pencil so that I can clean it up later and make a different choice. And now I'm going to substitute. So there's x2, there's x1. Notice how we have a double negative. We'll deal with that in the next step. Let me zoom it in just a little bit because I'm starting to write kind of small. Here is y2, here's y1. All right. You have two options here. You can either do this by hand or run it through the calculator. And honestly, it doesn't matter to me which way you do it. Let me show you both ways. I'll show you in the calculator first. So we're going to go to our calculator. Yikes. All right, there we go. I'm going to go to calculate. So I push the little calculate button, and I'm literally going to type what I see here on my paper. So the square root of, open parenthesis, -6 minus -5, close the parentheses, square that. Then add, and notice that your square root bar is still going. That's a good thing. You want it to continue because we're still under the square root bar. -5, or -5 minus 2, close that, square it. Everything is under the square root bar. All of my symbols seem to match up. I'm going to hit enter. All right, and I get some sort of crazy decimal. That works. Okay? Hi. All right, I'm doing a recording, so give me a moment. Thank you. All right, we're going to do the same thing now for B through C. So go ahead and grab your calculators if you have one. And let's fill in the information, thank you, that we need for B and C. So square root of, now I need to make different choices here. So I'm going to erase my markings for x2, y2, and x1, y1, and I'm going to make new choices. So this is now my x2, y2. This one will be my x1, y1, and I can go to town. Note, it doesn't matter which point you pick to be x1, y1, or x2, y2, you're going to end up with the same answer. Just make a choice, okay? All right, you're right with whatever choice you make, by the way. Okay, here we go. Here's x2, there's x1, square all of that. There's y2, there's y1, square all of that. All right. On this one, you can put it in your calculator. Those of you who are crunching the calculator, go ahead and do that. While you're doing that, I'm going to show you how to do this a little more manually before you go to the calculator. So I'm going to scoop my paper way over. All right, so I'm going to handle the stuff inside the parentheses first. -1 minus 0 is -1. Over here, I have a double negative right here. So you can turn that into positives because two negatives become a positive. And I have -4 plus 1, that is -3. And I'm going to square all that. -1 squared is 1. -3 squared is 9. And so when I'm done, this should end up being the square root of 10. And when you type in the square root of 10 in your calculator, I traded calculators with my partner who is sitting here next to my side working with me. She's staying real quiet, that's why you haven't heard her voice. Okay, so we end up getting 3.16, which means this is not a parallelogram because those distances are not the same. If the distances had been the same, then we'd been like, awesome, let me check these other two sides. And you do the exact same thing and check to see if those distances are the same. And if they're the same, those sides are congruent, and we would have hit, yes, this is a parallelogram. But since my sides came out different, according to my calculations, I have to write that no, A, B, C, D is not a parallelogram. And the reason it's not a parallelogram is because opposite sides are not congruent.
So to let you know, I finished checking off the stacks.
Okay, thank you.
you know, you can just go through it and, you know, whatever you, I know you got a lot right now going on, so.
No
I
problem.
tried to do as much as I could for you.
I
which
appreciate
did.
that.
So whatever comes, you know, the next couple periods, I'll help
Great.
you out as much as I can.
I appreciate that. Thank you. I'll be in a few moments to check that out. Thank you. All right. Apologize for the small interruption. All right, so we figured out how we can use this to confirm whether it's a parallelogram or not. We can also confirm, let's, I guess, write it here. Confirm if parallelogram. That way when you're going back through your notes, you know where to find it. But we can also use this to confirm if it's one of the special kinds of parallelograms. For example, if we wanted to confirm that the parallelogram we're looking at is a rectangle, we don't have to confirm that the opposite sides are congruent, because that just tells if it's a parallelogram. For it to be a rectangle, we'd also have to confirm that the sides next to each other are perpendicular. And so we'd have 8 things to do. And I don't know about you, but that's a lot of work. You can instead do this. Check if the diagonals are congruent. Because according to this, if diagonals are congruent, the thing's a rectangle. Well, if it fits all the properties of a parallelogram. So if you're told this is a parallelogram and the diagonals are congruent, it's a rectangle. For a rhombus, if you're told this thing's a parallelogram, is it a rhombus? You're going to use the distance formula to check that all 4 sides are congruent to each other, that all 4 sides have the same distance. If you do that, it's a rhombus. For a square, you have to check to see if your parallelogram is both a rectangle and a rhombus. Because the square is Superman and he has all the powers. So he's got all the properties of the rectangle and all the properties of the rhombus, which means in order to test him, you have to check that he has all the properties of the rectangle and all the properties of the rhombus. All right, so I hope that helps you out in using distance formula, especially to confirm if you have parallelograms or rectangles and rhombuses and squares and all of the things that you might need to use the distance formula to do stuff to. I don't know what I was going to say there. All right, thanks for watching. We'll see you on the next vid.